So in this clip, we're going to be calculating pressure. Now, if I add particles into this balloon by blowing into it, what happens is all the particles that are trapped inside the balloon are moving around randomly and really quickly, and they're colliding with the inside surface of the balloon, and they're pushing outwards and creating pressure. So if you've got a gas that is contained within a volume, the gas particles will exert pressure on the inside walls of the container. Okay, so there is an equation for this, and here it is. It's P, which stands for pressure, times by V, which is volume, equals K, which is a constant. And a constant is the number if you times the pressure times by the volume. So let's do a quick calculation. But before we do, if I was to blow up this party balloon, which I have done and you've seen Millie do, in a balloon, the average pressure is around about 4 kilopascals, because pressure is measured in Pascal. So 4 kilopascals is 4,000 pascals. Okay, let's look at an example then. So coming back to our equation, so P for pressure is measured in, what's pressure measured in, Millie?
The unit for pressure is the Pascal.
That's right, the Pascal. So that's PA. Volume is measured in meters cubed, and then we've got our constant here, which there's no unit for. So let's look at an example. So an example is that we're going to have a gas. It's held in a container that has a volume of 15 meters cubed. Now this gas exerts a pressure of 30 kilopascals. So 30 kilopascals is 30,000 pascals. We're going to leave it in this unit, and we can work using this equation. So the first thing I'm going to do is I'm going to work out what K is, what the constant is for this setup. So K is going to be P times by V. So P is 30 times by 15, which equals 450. So this is our constant K. Now, if I was to increase the volume of the container, bearing in mind that the temperature stays the same, if you start messing about with the temperature, you can make the gas pressure go up or down. Gas pressure will increase if you increase the temperature, because the particles have more energy and there's more collisions, and pressure will decrease if you decrease the temperature, because the particles will be moving around slower, hence less collisions. So let's get back to our question. So I'm proposing that what we're going to do is we're going to increase the volume to 45 meters cubed. So theoretically, we are timesing the volume by 3, which means that the gas pressure, if the volume increases, the gas pressure goes down. Therefore, we'd expect the gas pressure to go down 3 times. But I'm going to put it in the equation and just show you that it mathematically does work. So let's put our magic triangle, because we like those. So you've got P times by V, and we've got K up here. Okay, so we've put this into our magic triangle. So we're trying to work out what the new pressure is with our new volume 45. So our new pressure, P, will be K divided by V. Well, K, there's our constant, is 450 divided by V, our new volume, which is 45, and 450 divided by 45 is 10. And if we come back to our units, the units that we were using was the kilo.
Don't forget the units.
Pascal. So there's your answer. So if we started off with a gas pressure of 30 kilopascals, and we increase the volume from 15 meters cubed to 45 meters cubed, that's an increase of 3 times. As you can see, the pressure has been reduced or decreased by 3 times. It's gone from 30 kilopascals down to 10 kilopascals. So after all that hard work, is there something in the fridge to give Millie a treat.
What's in the fridge?
Regarding a bit of Big Mac in there. It's nice. Mac, but just a little piece there that she can have. She has worked hard today, so yeah, come on in. Here's a bit of Big Mac. Have a bit of Ronald McDonald.